From work time to fun time, Azure Cosmos DB powers the apps that power your day. Rise and shine with personalized mobile and online experiences powered by Azure Cosmos DB. You get your Starbucks coffee your way. Gas up and go. Real-time vehicle diagnostics let you know if your connected car is low on fuel. Going up. No time to take the stairs? Predictive maintenance means a smooth and safe ride to the 10th floor. Sign in, say hi. The consistent reliability of Microsoft Teams keeps the collaboration going wherever you are, using Azure Cosmos DB as the primary data store. Learn something new. Built on Azure Cosmos DB, ChatGPT's always ready to answer your questions and converse with context. See who called. Secure storage means your AT&T voicemails are ready when you are. Order up. What were the groceries you ordered last week? Walmart makes reorders easy with all transactions served by Azure Cosmos DB. Check your balance. Fidelity's secure real-time transaction processing means real-time financial management. Finally, vacation. No sitting on the tarmac for you. Azure Cosmos DB powers fuel management for JetBlue. Your modern life is built on modern apps. And modern, intelligent apps are built on Azure Cosmos DB.
Hey everybody, my name is Jay Gordon. Welcome back to our monthly Azure Cosmos DB Global User Group. My name obviously is Jay Gordon. It says it right there, and I just said what my name is. As you can tell, I haven't done this because we took it off last month. Had a really lovely vacation, got to go to Iceland, got to go to Norway. Very, very happy that I've got some time off. And if you haven't taken off some time, I want to remind you, always take care of yourself. Take a few days off if you can. Take maybe a lunch, go spend some time with a friend, whatever. Just take some free time for yourself, especially while it's during the summer. If you're in a place like me here in New York City, I'm enjoying my summer very much. Anyway, enough about what I'm enjoying as far as locally here. I want to talk about what we're enjoying as far as technology and Azure Cosmos DB is concerned. And today we've got a really great topic. I've got an incredible guest. But before I get to my guest, I've got someone important to bring in, and that would be Askia. How you doing? It's been a month.
Oh, I'm great. I'm great, Jay. How you doing?
I'm doing really well. How's your summer been so far?
It's been good. I totally agree with you on getting away, taking some time off a little earlier before July, but earlier in the summer, I had a trip to Costa Rica, so got to reset my batteries and recharge, and that was awesome. So back and ready to go. Summer in Pacific Northwest has been great, so no complaints there. So yeah, I'm excited and ready to get this one going today.
Great. So we normally line up these user groups because, there's going to be interaction within our chat. We want to make sure that everybody feels comfortable and safe. And so that's what we're here to talk about first.
Absolutely. We definitely have a code of conduct that we'd appreciate that you guys take a look at. We posted it in the chat, and it's obviously on the screen. But basically, we seek to provide a respectful environment for all of our presenters. We want to encourage engagement in the chat, but we ask you to be mindful of your commentary, remain professional, please remain on topic. We will have time for questions throughout. So if you've got any questions, go ahead and pop those in the chat. We'll also share some useful links in the chat, so keep an eye out for that. The session is approximately going to run for about an hour, and it will be recorded and available on the Microsoft Reactor YouTube channel within about 24 to 48 hours after this live session concludes. So I will now turn it back to Jay and introduce our speakers for the session.
Fantastic. Thanks a lot. And I know we'll see you at the end of the show. Catch you later.
Thanks.
Great. So we've got things lined up, and now it's kind of time to talk about what we're going to be talking about. And then I'm going to bring in our guest. So today's subject is microservices and Azure Cosmos DB. Now, our guest is going to talk a little bit more in depth, but I just wanted to kind of put up some baseline information just to kind of get you up to speed on what exactly I'm talking about and what our guest is going to be talking about, and that are microservices. So microservices, think about it this way. For the longest time, we built applications in a monolith. And because of that, updating applications becomes a bit more difficult because you've got to put your changes into one massive code base, and that can actually get a little bit difficult. So what we're talking about is having different services kind of self-contained and working together so that we don't necessarily have to use an entire monolith. So let's take a look at some examples. This is just the basics, the minimum basics of what a microservices infrastructure would look like. But then as we find we want to add additional services into it, we start getting a little bit more complex. This is a great diagram that we have for infrastructure on the on the AKS infrastructure site around how you can implement microservices. And it gets even more complex the more you get into it. There's so many options to be able to basically have your services a little bit more loosely coupled, not necessarily having them all tight in one particular monolithic application infrastructure. So that being said, there's someone that I want to bring in that's going to actually give us a little bit more in depth on it. And it's our guest for this week is Tina Idnani. How are you today?
Hey Jay, I'm doing good, and thank you for having me here. How are you doing?
I'm great. I am so glad that you're here with me. I first got to know who you are because you took part in Cosmos Conf 2024. You did a really great presentation, and it was one of our best performing ones. People loved to hear what you had to say. And that led me to basically say, you know what? Here's someone that should definitely come on here at the user group and take part. So thank you very much.
No, thank you. I'm really excited to be collaborating with you again. And as you said, first time was great. And yeah, let's repeat it.
Absolutely. So one of the things I love to talk to my guests about is specifically how you got here. What brought you in your world of technology in your career all the way to the point where you're here talking to me. So just give me a brief summary about how you got here.
Yeah, sure. So I started my career almost 15 years back. I started as a .NET engineer back in India, like where we had two career choices mostly, either go into medicine or go into engineering. And because my maths was good, I kind of thought, yeah, engineering is my line. So that's how I ended up being a .NET engineer. I did that for quite a long time. I even moved countries. I came to UK 5 years ago, and there in one of my previous organizations, they were making a move to Azure, and that really excited me. Like just starting into a complete cloud-based solution, not just for a team but for the entire organization. So I got to witness it like firsthand, directly from the start, and it was so enjoyable and so amazing that I kind of knew that this is the way I want to move forward. So yeah, last 4 or 5 years, I have been doing more and more closer to Azure as much as possible. And being an engineer from background, I like building applications. So that's how when Azure Cosmos was released, we started exploring it, clubbed it with Azure Functions, serverless, realized how much powerful it can be for our microservices, migrated few of them, modernized few of them. So I just thought, yeah, now is the time to kind of share the knowledge and the learnings with the wider group. And that's how we started contacting. And
Fantastic. Yeah, I mean, one of the big parts about being in a community is being able to go out there and say to people, I learned something and I think you can benefit from learning it too. So let me create it in a format that I feel comfortable delivering and I think that you'll feel comfortable learning with. And I felt like when you did that presentation at Cosmos Conf, you did very much that. Basically, hey, everybody, this is what I've learned. I want you to understand it too. So I really can appreciate that and what you're giving to our community. So that being said, you've got some stuff to kind of give our community today. You've got a really great presentation. I am going to go ahead and bring up your screen. And what I'm going to do is I am going to give you the floor. I would love for you to go ahead and give your presentation. And I want everyone to know that if you have questions, please leave them in the chat. As we're going along, we'll see if there's stopping points, or we'll go ahead and answer them at the very end. So that being said, Tina, why don't you go ahead and take it away?
Yeah, thank you so much. So yeah, welcome everyone. Thank you for having me here. I'll jump straight to our agenda. That is just one second. Yeah. So for the next 30 to 40 minutes, I'll be talking to you about how Azure Cosmos DB can power up your microservices. It is going to be a demo / code heavy session, hopefully an engaging one. We'll first start by looking into microservices in Azure Cosmos DB. Then we'll move on to some key features of Azure Cosmos DB. And then through a demo, we'll see those key features live in action in context of a microservice scenario. And towards the end, we'll take a look at some best practices and considerations, and we'll open it up for question and answers. So let's start. Jay gave a really good introduction about microservices, so I'll not go very deep into it, but I'll just kind of recap it that they are like small independent services that work together. Now, why are they so much preferred while designing and building modern applications is like they are loosely coupled, meaning changes in one do not mess up the others. You can deploy them independently, so no more massive, scary deployments. And they also give you a lot other advantages like, they're modular. Each service does one thing and does it well. It's scalable. Scalability is a breeze. And, if you need more power in one area, scale that service and leave the rest alone. You also can do tech diversity in it. If you want to try a new framework, go for it in just one service. And they are resilient that in case one service trips, your whole application doesn't break. Now that we have our microservice, let's talk about where we are going to store all the data these services need. So enter Cosmos DB. Now, again, Azure Cosmos DB is a very versatile, globally distributed database service. I like to compare it with, Swiss Army knife kind of an analogy to emphasize on its multi-purpose nature. And I'll get to its features in the next slide. But for now, you can say that Azure Cosmos DB is like a foundation for global scalable apps. And it's very useful, particularly when you need your data to be available globally with low latency, or your app needs to scale rapidly, or you're working with various types of data and you need flexibility. So these are some key features of Azure Cosmos DB, like globally distributed. It enables you to replicate your data across multiple Azure regions worldwide, ensures low latency, data access for its users. It's multimodal, means it supports multiple data models. You could use document data, key value pairs, graph data, all within the same Azure Cosmos DB account. You get automatic and instant scalability. It basically offers virtually unlimited and elastic scalable throughput across any number of Azure regions. And the best part is that there is no application downtime. And then there is high availability in case of any regional outages. So now picture this. You've got your modular scalable microservice architecture, and you pair it with a database which is just as flexible and scalable. And that's where the magic happens. And what we are going to see is exactly how the combination of them is so powerful together. So for that, we are going to jump quickly into a base application demo. We'll talk about a common microservice scenario. I'm not going for a complicated one. We're going for a simple serverless kind of a microservice scenario. So just imagine that you have an e-commerce application. A customer makes a purchase. There's a checkout that happens. So you have a order service which will create an order and it'll send either a command or an event, depending on what kind of an application you've built, to maybe some relay messaging service, which can then trigger other services into action. So, you can have your inventory service updating its inventory based on the order, or you can have your invoice service, which could be initiating the payments, and then you could have notification service sending a message to the customer, like, something like, hey, your order is placed. So now let's see how you can use Azure Cosmos DB here. Okay, so what you see on the screen is we've created a pattern using Azure Cosmos DB, which acts like our persistent data store. And it also handles eventual consistency. Again, a little bit, I'll come to it in later. And also notice we have used change feed here. That's another feature of Azure Cosmos DB. And it so helps it that instead of dealing with complex two-way synchronization between services, you simply have, your individual microservices, for example, let's say invoice service, consume the change feed from the events which are persisted in this Azure Cosmos DB. So it acts like a very powerful tool for building event-driven architectures where services can subscribe to and react to data changes, decoupling them from each other while still maintaining the synchronization across the distributed landscape. So in fact, this is a Microsoft recommended pattern as well, using Azure Functions and Azure Cosmos DB to build globally distributed, scalable, serverless applications. So if I could just take a minute and explain about this architecture, again, something very similar to what we saw earlier. A customer places an order in an e-commerce website. Now that triggers an instance of functions. So you have a checkout API function, which processes the customer's checkout and stores information about that order in an Azure Cosmos DB. Now, that database insert operation that happens, it basically triggers an Azure Cosmos DB change feed event. And all the systems that have subscribed to that change feed events are notified and they can take their own action. And that is exactly similar what we are going to look into the code. So let me take you to the code. This is available on GitHub. The links will be shared, and they're also at the end of the presentation. So again, not very fancy. These are very simple demo that I'm showing here. You have basically different microservices here. One doing the order service. You can see it'll have functions. So let's just go back. Yeah, to the functions. It'll have, a create order function or a get order function. It has those things. Similarly, you have other services like notification service, order service, etc. If I take you to our Visual Studio Code, I have the same structure here. In fact, what I've done in advance is I have actually locally run these APIs, these functions locally. I've not deployed them to Azure Function, but they are here available locally. And if we were to, let's say, through a Postman, if we were to invoke these APIs for create order, it'll exactly go and perform what that operation is supposed to do. So for example, if we do create order, let's just say customer ID is number 100. They want to purchase a product ID, which is 50. They want to purchase 5 items of it, amounts to 3,500. And you click on this. So what will happen behind the scene is the order will be created. And if I show you where in the Cosmos DB, so if you come to the portal, this is the Cosmos DB that I've integrated with my application. And in this, if we go to Data Explorer, we'll see we have different containers for different microservices that I've used here. I'll just wait for it to load. Yeah. So I'll go into orders. I'll go into items. And let's look at the last item, which was hopefully the one that we inserted against customer ID. So that the create order API executed this and an order was created. So this is a very base implementation of our APIs integrating with Cosmos DB. Now, so with that base in place, let's go to our few key features that we want to talk about. And the first one is a very cool feature of Azure Cosmos DB, that is partitioning. So for that, in Azure Cosmos DB, you choose a partition key. Now it can be either a customer ID, depending on what your data is about. Now, data with the same partition keys, they stay together, and Azure Cosmos DB automatically, it spreads your logical partitions across multiple physical partitions. Now, why is this partition strategy so great for microservices? Because scaling becomes a breeze. Both your applications and your data can scale independently. Azure Cosmos DB can easily add more physical partitions. And not just that, queries that use the partition key are also super fast. And then in case if there are issues in one partition, they'll not affect the others. So what you see on the screen right now is how you can specify a partition key while creating a particular container. So let's imagine if you were creating an orders container, you want to choose the partition key as customer ID. Now let's see that in action. For that, I'm going to bring you back here. We are going to look into the settings of our orders container. And if I go into the partition key, you will see here, this is where we have specified the partition key as customer ID. Now let's try something. Let's try to retrieve data using this customer ID. Okay, so for that, let's write a new query. Let's just say select star from C, where C dot customer ID equal to, let's say, 100. This is the one that we want to execute. Sorry. Yeah, there you go. So you get your data, you look into the query stats, and there are certain RUs are charged against it, which is 2.83. Now let's try and do something else, maybe something like total amount. Okay, and let's see, we want to search for a total amount of 3,500. So when you execute that query, you see that you have got a slightly more charge, RSUs, RU charge. Usually, depending on, there are just few things to remember here. What happens is sometimes, if you will not see a very difference in the RUs, because one, you could have a small data set. So if your container doesn't have much data, then Cosmos DB might perform a full scan regardless of a partition key. Then sometimes it also depends on your data distribution. If most of your data is in one partition, queries might cost the same based on whether you've used partition key or not. You also have an Azure Cosmos DB's query optimizer, which might have found an efficient way to execute it. And then we also have indexing policies that might be making non-partition queries also more efficient. But I think the point that I want to say here is that whenever you are creating a container, please do choose an partition key effectively, and be aware of what is the volume that you are expecting in your database account, in your particular container. That will help you choose your right partition key. So with that, let's go to our next feature that we want to showcase, which is global distribution. Now, okay, so far we have broken down our application into microservices. We have also partitioned our data smartly, and we want to go global. So how you can do that? You can do that by enabling something known as multi-region rights. Now, why would you want to enable multi-region rights, or why would you want to go global? Because microservices, they can operate more efficiently on a global scale, for providing better performance, reliability for users worldwide. So if we just take our own microservice example that we are talking about, right? So imagine we have these microservices deployed across 3 regions, like US East, Europe West, and Asia East. Now, how will enabling multi-region right benefit our users? So imagine if you have a user sitting in, let's say, East US creating an order. So how will that work in our order service? Well, that order service will write the order data to its local regions database. That data will then be replicated to other regions asynchronously. And you will also notice that the users will see faster order placement for customers in each region. So basically reduce latency. Then you can also have improved availability in case one region goes down, the other region will continue, etc. So what you see on the screen here is how can you enable, once you've enabled the multi-region write, which we will see, is how can you have it in the code to say what is the primary region which you want your microservices to serve. So in this case here, it is East US. Okay, so let's do that. Let's see it again in the portal. So if I take you back to our portal, we have come to the settings. We have this setting called as replicate data globally. Now this will kind of show you that right now, this particular account, I have disabled the multi-region writes, but if you were to enable it, it will allow you to then choose a second region. So if you click on add region, maybe you can choose another region. So let's say West Europe, and then you can say okay, and then you can choose whether it has a write enabled or not. So this way, this particular Cosmos DB will have a write enabled for North Europe and West Europe, and then basically you can have two microservices for order service, one in North Europe region, one in West Europe region, each serving its own local region. Okay, so this is how you would do it in the portal. And if we want to see it in the code, so for that, let's go to our one of the services. Let's say the order service. Let's go to the program.cs. Now, this is where I'm configuring my service and I'm creating my new client. So while creating my Cosmos client, I'm giving it some client options. And you can see I'm reading it from my local settings, the primary region. So this is where you are specifying that your microservice is going to be writing and reading from the first region, which is the primary region, which let's see here is, let's say, North Europe. Okay, so that's how you will go on and do it. When you click on save, it is going to take some time based on the data that you have in your Cosmos DB account, because in that container account, in fact, the whole, because it has to do a replication as well. So you might find that it'll take an overall some time. Okay, so with that, let's go to our next feature, which is consistency level. Now, this is my personal favorite because I think one of the cool things about distributed database platforms is that they are no more what they used to be a decade earlier. You know, like earlier we used to have two consistency levels, either strong or weak. But what I love about Azure Cosmos DB is that they have 5 consistency level. And when I was starting to explore Azure Cosmos DB, I was really excited because I had so many different use cases where I used to hack around consistency. So this was very cool. So let's just quickly talk about those 5 consistency levels, right? The first is strong consistency, which means if you have a write, you do a read, no matter where you are, you're basically going to get the last write. So you lose nothing. Then you have bounded staleness. It basically means you're always going to lag a little bit behind your writes, and you can lag either by number of commits or by time, let's say 5 to 10 milliseconds behind the latest. And then you have session consistency, the most popular of all the 5, I guess, because think like this. Imagine you went on Amazon.com, you added your review, and you were able to see it immediately because they're giving you a session level consistency. However, if someone else right then basically goes to Amazon.com and looks for the review comment that you added, it might not be there for, let's say, another 5, 10, 15 seconds. And that's okay because, because it's session consistency. So there is a trade-off. Then the fourth one you have is consistent prefix. As you will see, the name itself says that there is some sort of ordering here. And this is exactly what you'll get, that you may be behind, but you will never be out of order in terms of the consistent prefix.
And then you have the final one, which is eventual consistency. In this, basically, you can be completely out of order. You could be doing reads and you may be getting things which are not in order, because it is the loosest consistency out there, but it is also least expensive in terms of throughput. And yeah, that's why it's called eventual consistency. So the good thing about Azure Cosmos DB is that it provides tunable consistency levels on like a per request basis, allowing developers like us to balance latency, throughput, consistency as the application needs. So this is how you can choose the right consistency level. If you're doing a read and you're okay to get your reads out of order, you can kind of, when you're doing your read, you can just say consistency level as consistency level.eventual, and it'll give you the read that it gets you. So let's see that in action. I'm going to take you back to my code. This time we are going to go into one of our repositories. And over here, you'll notice we are doing a create order and we are doing a get order. And when we are getting order, basically the same that I just showed you earlier, when you're doing a read item, you're agreeing that, okay, I can have an eventual consistency. You may also have scenarios like imagine if you're doing a bulk update behind the scene, and you know that it is going to take some time because of the replication and etc. You can always again then do that using eventual consistency. So check your scenario, what kind you have, and on the basis of that, you can have different consistency levels. If you need session consistency, use session consistency, but see what exactly do you need. Yeah. So with that, let's go to our next one. Again, very important, which is change feed. So, okay, so think like this. You've gone global. We have seen how we can use consistency, how we can use partitioning. Now, let's talk about how our microservices can react to changes in real time. And okay, that's where change feed comes into picture. Think of it like a notification system for your data. So what are the benefits of using change feed? Like I said, real-time reactions. Your microservices instantly respond to data changes. Well, decoupled services, but they stay in touch with each other. They stay informed about each other without directly querying each other. Then you have event, they are really perfect for event-driven architectures if you want to build responsive event-driven microservices. And they're also really good for scalability because your change feed processor will automatically distributes work across multiple instances. And if you talk about reliability, it guarantees at least once processing of all the changes. Okay, so let's implement this in like I have already implemented it in our inventory service. So let's go take a look at it. So if I come to inventory service, inside the functions, you have this order created trigger. Now, you will notice here, this is a Cosmos DB trigger, which means that it is listening to all the changes that are happening in a Cosmos DB account. So this is the database name. This is like, you can connect to it using this connection string. This is the name of the database. This is the name of the container. So basically, if any row is inserted, updated, or deleted in orders container, it's going to be processed here. And what it's going to do is it's going to process each and every document which is updated or inserted. And let's say in this case, it's going to update our inventory based on the order that is created. So if I come back to our demo again, so let's see. We have this, let's see this product 50 right now, how much quantity it has. So if I just go to our get API, so, and I want to see what is the current number of quantity. Okay, it doesn't have any quantity here. So first what I'm going to do is I'm going to update the quantity. So I'm going to do product ID 50. I want to add 20 items. Okay, so I've added 20. I go back. I see If it has 20, yes, it has 20. Now, if I go back to my create order API and this order, this product 50, I'm making a placement, I'm making an order of 5 units of that product. So what I want to see is right after, whenever this API will be executed, an entry will be inserted into the Cosmos DB account, the order service container. And as soon as an entry will be inserted there, that order trigger function, the order created trigger will pick it up and it'll process it. And in processing, it's going to reduce the inventory by 5. So let's run it. Yeah, it did run. Now, if you were to do the update API, if you were to check the get API for inventory again, you will notice that the quantity was reduced by 15. So going back to our code, just to re-explain what exactly happened, when a row was inserted into the orders container inside this Cosmos DB account, then it goes and basically it calls the update inventory API. It reduces against that product. It reduces the quantity. So this is a very simple logic, but the point here is that you can do different things based on the live, the real-time updates which are happening to one particular service. So if you see, this is the order service. I've done a little bit of logging here. So when it executed the create order function, if you go to the inventory, you will see an order created trigger happening, which is updating the inventory for 50. And then when we did a get inventory call, it basically showed us the reduced quantity for that particular product. So this is how, with change feed, our order service and inventory service are now both in perfect sync without being tightly coupled with each other. So this is literally the power of combining microservices, Cosmos DB, and change feed. So yeah, there are more features of Azure Cosmos DB that can be used in microservices. You have order scale throughput, you have time to live, but again, I didn't want to make this, overload. So with that, I think let's jump to our last section of our session today, which is more around best practices and considerations. So let's see what are some of the best practices that you can incorporate in your programming while building your applications. So if you're using global replication of Azure Cosmos DB and you have enabled multi-region writes, there are a few things that you'll need to handle. Inconsistent reads, because imagine you can have 2 different users writing to the different instances of your same Cosmos DB container. So one way to do that is you can use session tokens to ensure that you get the latest write in your session when you perform a read, and you also handle conflict resolution. You would have seen, if I just very quickly go back to order service, there was one place where I've handled it. So basically, when you are trying to create an order, and imagine if there is a conflict, then you somehow need to explain what you want. You can implement your custom conflict resolution strategy here, or you can even use like a very simple, like last writer wins. Whoever has written the last write will get to get that entry in. Okay, so you will need to handle those things. Then using change feed is a very good option because it puts your services in perfect sync without being tightly coupled. So if you have a scenario like that, think with an event-driven mindset and try and use change feed. Then asynchronous programming, again, a very common best practice and recommendation for microservices in general. And we'll definitely recommend to embrace asynchronous programming patterns when working with Azure Cosmos DB. If you're using .NET, then use your async await pattern or the appropriate asynchronous constructs in your language of choice. And make your operations idempotent, your write operations, so that they can be safely retried. This is pretty crucial when dealing with potential network failures or transient errors. So just that, this is great fun to use your Azure Cosmos DB with microservices. It really powers up. There are a few considerations that you need to handle in your code, but if you've done that, then you're really good. So with that, we come to an end of my presentation. There are some resources here on the screen for you to get started today. So I have my full source code, whatever I showed you right now, a very simple application, but kind of gets you a starting point into how can you integrate your Azure Cosmos DB and use its features in your microservices. Then if you haven't tried Azure Cosmos DB, well, I'll say go give it a go. It's free to try. You don't even need to have an account for that. And then if you're interested in really like mastering your Azure Cosmos DB, there is a certification path for it. Feel free to, there are a lot of Microsoft Learn paths. You can also use them to improve your understanding around Azure Cosmos DB. Yeah, that's how I kind of did it. So let's open it for questions. And my details are on the screen in case you want to connect. Let's do it.
There's your info again. So yeah, if anybody has questions, this would be the opportune time. And we do actually have a few. So why don't we pull them up and see if we can give some people some answers. What do you say?
Yeah,
all right.
Let's do it.
So first we've got one from Fikal, how to monitor the change feed events to ensure that all events trigger the Azure function to avoid silent missed ones. I'll let you tackle it first, but then I've got some answers.
Yeah, I'll suggest, have your observability in place, have your Azure monitor, make use of application insights.
That's exactly what I was going to say.
Yeah, and I'll suggest do proper like error handling in your application, retry logic. You can even use dev letter queues for your failed events.
That's exactly what I was going to recommend also. Dev letter queues, set up your health checks. If there's something that's supposed to happen as part of it, set up a health check. Like let's say it's supposed to leave a file somewhere, or it's supposed to have a new entry into the database. You can always use change feed to go ahead and update that, then send a notification when it fails. So yeah, build your applications with some resiliency and include that in how your infrastructure looks. You want to make sure that when you're building, you won't really have to concern yourself too much with things failing because you don't know about it. Let's face it, one of the big reasons why things fail, and they fail for a long time, is because we don't know that they're failing. We haven't set up monitoring, we haven't set up anything. So, so we've got another question here, and it is from Daryl. I will let you tackle it at first, and if not, I have a couple of little things to consider. But what does it mean to set the partition ID on the read? Seems like it should be set when the DB is created.
Yes, so that is correct. You specify the partition ID when you're creating the container, so that whenever any insert operation happens, the data is inserted in the correct partition based on the partition ID. Now, I think what Daryl was trying to ask is when a while before, when I showed one of my operations, even in the read, when we are calling the read items async method, there we are passing partition ID. Now, I think if I understood it correctly, that ID is to retrieve the information. Like if you want to read a particular customer ID, for example, you need to read the value of customer ID 100. You need to pass that ID there in your get. This is what I made of the question. Jay, I'll be open for your interpretation as well.
There's some other reasons why you would set the partition key on read, basically for efficiency. So you don't need to scan all those different partitions and end up incurring, the other reason why is costs, because you don't want to have queries spanning multiple partitions and creating just more RU usage. So we want to be able to utilize these things that we have built into it and avoid
Yeah.
spending more. And that's the gist of it. If we don't have
Yeah,
any
it'll make your querying more efficient, right?
Yes. So efficiency is the key, because if we do things efficiently, like building our applications within microservices, we can see better performance, long-term viability of being able to make updates, and then overall costs. Cool. All right. And Daryl said, yeah, I saw the, let's take a look. I saw the customer ID and the partition ID on the read. Cool. All right. Well, Tina, I think we've come to the end. And with that, before you and I say goodbye to one another, I got to bring back Askia. How you doing?
Great session.
I agree. And I'm going to do what I always do, is I'm going to kick in a little bit of music to kind of get us settled. There we go. So Askia, tell me a little bit about what people need to know now that our session is over.
Yes, well, we always appreciate feedback. So we put the survey link on the screen, and it's also in the chat. So anything that you've got, any comments, we would love to hear it. So please go ahead and take a moment to fill that out, and we would greatly appreciate it.
I know I appreciate you, and thank you for going ahead and joining me every time we do one of these. It's really, really helpful to have you be part of these. So thank you very much. And I look forward to the one we're going to do next month. We've got it already. We're going to be talking more. You'll see lots of promo on it, all the different social medias and stuff like that. So thanks very much. And I also want to say a big thank you to Tina. Tina, thank you so much for helping us learn a little bit more about using microservices alongside Azure Cosmos DB.
Oh, thank you. The pleasure is mine.
Awesome. So is there anything else you got coming up you want people to be prepared for, to show up to, anything like that? Any other events, any other talks, or you just kind of getting through your summer as well?
I am actually. My second half of the year is going busier than I had expected. There is an InfoQ Dev Summit, which is in Munich, Germany, end of September. And I'm actually talking about quantum computing there. So I didn't mention in my introduction, but I do have a side passion for quantum computing. And I've been doing my research bits on the side around the applications where we can use quantum computing before the Q day comes, just to get ready. And I was really honored to be invited to do a keynote session there. So it's end of September in Munich, Germany. And then in November, I'm also participating in a Women in Tech, again, a Microsoft user group kind of an event. So I'll be talking more about event-driven there. So yeah, the next 2-3 months are really busy, and hopefully we'll go into a much-deserved holiday season in December. So Looking forward to it.
And we're looking forward to seeing all the great stuff you're doing. But for now, I think it's time that we all look forward to closing out this session. I want to say thank you to you both for being part of this session today. And I want to say thank you to everybody that was in the chat that takes part in this. We need your help in order to actually do these. And so I want to remind you that if you would like to, we have an intake form for you to fill out. If you'd like to do a presentation just like Tina did, please fill out this user group submission intake form. I'll put it in the chat as well. We'd love to have you as one of our speakers. We need your help. So that being said, we are all set for this month. I'm really looking forward to seeing you all next month. But until then, let's give everybody the big wave goodbye. Take care, everybody. Take care of yourselves, and we'll see you next time. Bye now.